The broadcast is now starting. All attendees are in listen-only mode.
Hello, good afternoon, and welcome to the 6th Hangout organized by CESSDA and Semantic Web Company within the Big Data Europe project. This time we'll talk about big data and the shift to trusted smart statistics. I would like to welcome my colleague and co-organizer Martin Kaltenbach from the Semantic Web Company and Fernando Reyes from Eurostat Task Force on Big Data, who is our keynote speaker today. But before we begin, I would like just to share with you some technical details. So for those of you who already participated in our webinars, you know that the webinars are being recorded. And if you have some questions for our keynote speaker, then you can write your questions into the chat part of the panel, control panel on your right side. And Martin will take them in the end. He will manage them, and in the end he will ask our keynote speaker anything you want to know further about smart statistics and big data. One more information is that handouts, so our presentations are in the section, handouts section, also in the control panel, so you can download them from there. But in the end, we will publish everything on the big data website. So our webinars usually work in the following way. It's always the same. So I do this introduction, and I will tell you in very short about the Big Data project and CESSDA's role in it. Then Fernando will take over and elaborate on his part. And in the end, Martin will manage the questions and answers session, and he will wrap it up. So I hope you will enjoy it. And let's start. So Big Data Europe is the 3-year project. It is a coordination and support action project, and it is reaching its end. So we are going to finish officially on 31st of December this year. Its main intention was to actually produce integrated stock of tools to manipulate, publish, and use a large-scale data resources. There are 2 coordination and support measures, one for coordination, one support. And the first one is engaging with a diverse range of stakeholder groups, and each group should represent particularity of the Horizon 2020 societal challenges. So there are 7 of them, so there are 7 groups. And then designing, realizing, and evaluating a big data aggregated platform infrastructure that was also produced within this project. The reason why the project has even started was to show societal value of big data, to try to lower barriers for using big data technologies. And there are, of course, many, because it requires efforts and resources. And of course, there are, up to some limit, data science skills that should be actually used, and there are not so many around. And then, in the end, help establishing cross-lingual, cross-organizational, and cross-domain data value chains. There are 3 V's in the big data. So data velocity, data variety, data volume. For social sciences and humanities, variety is extremely important, and it's often neglected. So although social sciences and humanities don't have what is big data in their most common meaning and sense, we have a lot of variety in our data. So that's why social sciences and humanities are actually part of this project, and it actually produced many valuable outputs for us. Consortium is from all over Europe. You can see on the map that Europe is actually quite well covered with beneficiaries in this project. There are in total 16 partners, and the logic is to have one technical partner and one networking partner, and they work together. So for CESSDA, Semantic Web Company is the technical partner, and we're working on the pilots for each societal challenge. So societal challenge 6, social sciences and humanities, is actually CESSDA and Semantic Web Company. Just a few words about CESSDA ERIC as the host of this domain. It is a consortium of social science data archives. It's a permanent research infrastructure. So we have become an ERIC in June this year. At the moment, we have 15 member countries across European Union and 1 observer, which is Switzerland. Slovakia actually became a full member this year. And in Big Data Europe project, we are, as I said, the main representative for Societal Challenge 6, which is Europe in a Changing World, Innovative, Inclusive and Reflective Societies. And our main role is to coordinate this challenge and to coordinate potential users of big data in the social sciences and humanities, and as well to build the interest group to collect requirements from these very specific groups concerning big data and to assist the building of big data infrastructure as an access point for social sciences and humanities. So just a quick overview of what is going to happen by the end of the year. Their final round of workshops and hangouts. So CESSDA and Semantic Web Company, or Societal Challenge 6, we had our final workshop in Amsterdam in September, and this is the very final hangout that we're going to perform within this project. So it's in a way our anniversary. It's the last one, and we're very happy to have you here today. Also, the final big data instance was released on 16th of November 2017, so it very recently. And it was quite a big event, and it was a webinar about it, of course. And for any other information that you may be interested in, you can check our website and SlideShare, Flickr, LinkedIn group, and so on. All the links that are on this website. So I would like to finish at this point, and I would like to give Fernando, our keynote speaker today, the floor. So Fernando, please.
Thank you very much, Ivana. Martin speaking. We are waiting for Fernando's screen, and I think it's coming up now. So we just had to change between two presenters sitting, one in Bergen in Norway and one in Luxembourg. But now we're there. So Fernando, I think the floor is yours. I hand over to your presentation.
Okay, thank you very much, Martin. Thank you very much, Ivana. So my main purpose today is to provide you the presentation with the reflection that we have been doing here in Eurostat concerning the future of official statistics, in particular in what it is related with big data. So big data is something that happened to us, and we would like to now have a look into the future and try to understand what will be the role of official statistics in this new world that is approaching us. So to take a little bit more control. So for that, today what I will do is give a bit of an overview on big data, on the present, what we would call the present big data, and the implications of big data for official statistics, and what we in European official statistics are doing to address it, and then look a bit into the future, in this interconnected future world where smart technologies will be everywhere, and try to understand what will be the role of official statistics in that world. We call the statistics in that context smart statistics. We will then look into some enablers that can help us make that smart statistics happen. And finally, a roadmap to try to reach that point. So, as I was saying, big data is something that happened to us, and it basically, as a result of the huge amount of data that became available to us, resulting from the datafication of our lives, the digitalization, the widespread use of digital products, and the resulting datafication, the conversion of every aspect of our lives, of our behavior being transformed into data. And also the fact that now we have the capacity to store that data and process that data using distributed computing, it basically gave us the opportunity to explore that data and learn what we could do with that. This is basically the situation in which we found ourselves, and that we have been trying to address. This data is a new type of data. So it differs in several aspects to the data that we in the past in the social sciences and in official statistics we had available to us. It has a much more high detail and at the same time a much higher dimensionality. It means for each of our normal statistical units, individuals, our subject of study, there are many different traits that you can derive. And so this poses several opportunities and challenges from the statistical point of view. And this, at the same time, this is an exhaust data, meaning that this is a data that is resulting directly from the human activities. So this data is collected automatically, and this is what allows us automatically from either unintentionally when we use information communication technologies, or also captured by sensor that we have placed ourselves, either for statistical purposes or for other purposes. So these new data sources, they pose several opportunities and several challenges for official statistics. So it's there is a possibility with such detail, such high dimensional data, to create new types of statistics, new types of products, statistical products that we can create, and also much higher timeliness to what has been possible so far. But at the same time, it brought some challenges. The methodologies that we need to employ to use such data are different. The quality frameworks that we have developed for our traditional data sources, they most probably need some adaptation so we can continue using them. And at the same time, we find ourselves in a very different world where we are no more near monopolistic of the creation of data about the society, economy, and the environment, to find ourselves in a world where there are many data providers. So in order to address these challenges, to assess the opportunities, the potential of these data sources, in European official statistics, we have launched an action plan that we have now been running for 2 years. So this data is coming basically from 3 sources. First one is human source data. Basically, data created by humans via social networks. We have web content, we have also books. And so this is a data that is in a different format. It's in natural language textual data. It's in the form of behavior data. That's the first source of official, of big data. But the second source of big data is what we call process-mediated data. And this is basically IT systems that are installed in either public institutions or private institutions, and they support some process, some business process. For example, in the banks for the use of credit cards. These systems, of course, they capture and store huge amount of data of a very high detail level. And so this is a second source of big data. And the third one is that is basically generated by machines. It's either by sensors, which collect data, either they collect the state of the world or the state of the environment in a very high frequent rate, or they register events in an automatic way. And secondly is all the data that is flowing around between sensors and between devices while they communicate with each other, in what we are calling the Internet of Things. And I would like now to go into more detail into this Internet of Things, that this moves us to a vision or a perspective of what the future or the data layer of the future will look like. In particular when it comes to smart technologies and smart worlds, smart systems, smart devices, and so on. So the Internet of Things, in fact, it's a network that connects smart devices in the context of smart Systems, and in particular, it uses the internet, therefore the name. So, and this has been increasing an exponential way. In fact, in the future, most of the big data will be created in the Internet of Things by sensors, by smart devices. So, in our perspective is that we need to actually pay great attention to what is happening in this world and try to address it. So what I would like to do is look a bit into the future and to see what is it that we're talking about or what is going on, so we can understand what is the data layer of these technologies, and how we can use it, what it means for us. So I will distinguish three things: the smart technologies, the smart devices, and the smart systems. So smart technologies are technologies who present a few characteristics. They adapt automatically, meaning they adapt their behavior. They do it, in a sense, by capturing information from its environment. They do this via its sensors. And then by drawing conclusions using a set of rules. So they adapt their behavior based on information they have about the environment, and they draw some conclusions about that environment, and they try to work as much as possible as autonomously. So they have this capability of learning, and at the same time, at the most higher level of these smart technologies, they will have the ability to even self-generate and self-sustain in the future. So smart technology has been used for quite some time, in particular in the development of smart devices. So the smart devices now start to spread all around us. The smartphone is one example, already with some years, but we see it more and more, the emergence of these smart devices. Smart devices have three characteristics. The first one is that they are connected. They connect via the outside world to other systems, to other devices. Secondly, they are interactive, meaning that the user of the device can interact with the device by entering information, and the device reacts to that input from the user. And thirdly, they, to some extent, they have some kind of intelligent or cognitive behavior. And this can be in two forms. On one hand, it has some kind of predictive behavior, so it uses the interaction, tries to predict the needs of the user in the future, and also it has the ability to somehow work autonomously without the user intervention. So I would like to show one example of a smart device that is very much close to us as final users. So, for example, a smart fridge. The particular smart fridge that you see on the picture, it has the possibility for you to see what is inside the fridge at any time. Every time you close the door, it takes pictures using 3 cameras that are inside the fridge, and it has a screen on the door which you can use to have an idea what is inside the screen, but you can also access via the internet with your smartphone and inspect, for example, if you're shopping, what you have in the fridge and what you need to buy. So you can see that it has some connectivity associated with it. You can also get expiration notifications. So if some products are getting expired, you will receive a notification from the fridge. Now this expiration date is introduced manually by the user. We can imagine in the future that such information could somehow be automated and automatically either got from the product or even via the internet with identification of the product to identify somehow the expiration date. You can also create shopping lists, and you can even shop directly from the fridge. Of course, these are the features that are more related to what we would normally associate with the fridge, but it also does other things. It can create a calendar, it can display photos, you can stream music and video from your fridge to your living room, to your Wi-Fi system, and you can even synchronize it with your smart TV in case if you're watching a movie and you want to go back to your kitchen and still watch the movie. Now, of course, a lot of these features you would think, why do you need it in a smart fridge? Of course, these are technologies that are being developed, being tested. But you can already see characteristics here that there is connectivity, there is interactivity, and in terms of intelligence, I would say it has some intelligence. So this is an example of a smart device. Of course, that in terms of the data layer of this device, it doesn't seem the most useful one, but there are smart devices being introduced also in other aspects of our life, in other aspects of our economy. So, of course, the smart devices are in itself a smart system in a small scale, but of course they connect with each other in higher levels of aggregation. So you can have smart homes, and from homes you can have smart buildings, smart energy grids, smart cities, and in all these cases, we will have these characteristics of connectivity, somehow cognitive computing associated with the system that predicts the needs of the users and is able to function autonomously. Now, these are, to some extent, are the reality. So a lot of research has already been happening, particularly in smart cities, for some years now, and the technological conditions required for these systems to develop, they are now being reached, in particular with big data technologies. So that is a picture of how we see the world, and our objective is now try to understand what is the data layer of this smart world, because all these systems, what characterizes them is they require a huge amount of data in order to function. And this goes from the data that is collected by sensors in small devices and how they actually share this data between each other, and with higher level systems like homes, like buildings and cities, in order to help the management of for example, a city. So for us, we try to understand what does this mean then for official statistics? What will be the role of official statistics? So this is when we start thinking about and talking about small statistics. There are two ways in which we think that the smart world will influence the way we do statistics. The first one is that the data capturing and processing, and in fact all the data life cycle, will be or will need to be embedded in the smart systems themselves. And secondly is that we can see statistics also a smart technology itself, or it can transform itself into a smart technology. So why embed it? Why do we need to embed the statistics themselves into the smart system? Well, one obvious reason is because the smart systems themselves, they require statistical reasoning in order to function, right? From our point of view, for the production of statistics, for the statistical work, there are basically two reasons why we will need to embed the data processing, data capture and processing. The first one is the scale at which it is happening. We're talking about extremely high volume, much higher levels than what we have been talking about when we talk about big data. So already now, for example, the data that is captured by the system of a mobile network operator, it can be stored in their systems only temporarily, maximum for 1, 2, or 3 years. Afterwards, it doesn't matter if storage space is cheap, if it is available. The fact is that we're talking about levels of data capture and of a velocity that does not require the traditional way of thinking of producing statistics or doing research, which is to, at least for producing statistics, which is to move the data to a central place and then to process it. So for regular production of statistics, this will simply not be possible anymore. A second factor is that with the emergence of big data analytics, basically the user, decision makers, they are starting to understand the benefits of having very quick data, very quick insight drew from data. And we in official statistics, we have to address this reality. We have to embrace this reality, right? So our users are used to get very fast data with very high granularity. And so we run the risk that if the official statistics is not timely enough, by the time that we have our official statistics available, decisions have already been made. So it will arrive too late. Decisions taken based on information provided by other providers. So the second element is of smart statistics is to try to see how smart statistics itself could be a smart technology. So how can it be interactive? And so interactive would mean that we will take into account the users and the users' needs by allowing the users to provide feedback while they are consulting the statistics, while they are using the statistical products, right? And we have seen already some examples, not in the context of smart systems or Internet of Things, but even with traditional statistics, the possibility to somehow get feedback from the users has already been introduced. And then that feedback from the user can actually be used to improve the statistics, or even for the production of statistics itself. So it also could be, we could imagine this statistics as being embedded in an intelligent process. So how could this be happen, or in which way this could happen? So and the first way is that it could anticipate users' needs somehow, based on the information that has been collected from the users. The whole system, and that, given that the data capture and processing is embedded in the system, data storage and the processing somehow could be adapted. And finally, something, a concept that is very near to us is that even the concepts that we have been using in statistics and the algorithms could actually improve autonomously. And here I would like to give an example. Something that is very important when using location data, for example, in the context of mobile network data, is determination of home location of an individual. So it's from location data captured by the mobile phone network, to determine where does a person live. So of course there are algorithms that you can adopt. You look at the location of a person during the night, how regularly the person goes to that place. But of course, these algorithms can be improved if in a smart system we have information from other sensors, and we can use it to improve the algorithm, or improve the accuracy of the algorithm that we are using to determine the home location of a particular individual. This is an example of how the algorithms could be autonomously improved. So how could we make this happen? So there are several elements that that we need to take into account. So the first one is trust. So the trust in the system is required, and I will go afterwards a bit more in detail into it. The development of the standards, and finally the collaboration between the industry, the research and statistics communities. Collaboration more even in the sense of a joint endeavor in order to make it happen. Right now, when we talk about, we are talking about using the systems to produce statistics for our purpose, but in fact the systems themselves, they actually need statistical knowledge. They need the statistics to be in fact embedded in the system themselves, and the research community and the statistics community can actually partner with industry in helping to set up these smart systems now as they are being set up, as the standards are being developed. So when what concerns trust, it is very important for official statistics, of course, as they, by definition, they need to be trusted, right? So, and we need to guarantee trust in official statistics basically in two ways. First is the validity and accuracy of the outputs if the official statistics are not trusted, they are not believed to be the best that we can produce given the data sources we have available and the best methodologies we know about, they will not be used, and they will not serve the purpose of informing a democratic society, of informing policymaker. They will not fulfill the main purpose. Secondly, it's very important that in official statistics, we properly handle individual personal data. Now, this has been built into the statistical system. So national statistical laws, they almost always will include as a basic pillar not only the independence and the authority of statistical office, but statistical secrecy. The guarantee that all the data that was collected for statistical purposes will only be used for statistical purposes, and no individual data will be used for any other purpose. So it is very important to maintain this principle. Now, when we talk about very detailed data, there is a new challenge. The fact that this very detailed data ends up revealing aspects and behavior about individuals that they might consider to be part of their private life that they do not wish to share. In fact, many statistical systems, they put a limit in what information. They put a limit on the information statistical office can be collected, in the sense that no private data about sexual orientation, political affiliation, or the belonging to an ethnic minority, they cannot be collected by the statistical office. So there is now a particular challenge that not only the data subjects very often will not be aware in this context, in the context of an interconnected world of smart devices exchanging data and reusing that data, data subjects will not be aware about what data is being collected about them, how it is being used. So it's very important that we find the ways to build in the system themselves the trust and the protection of the privacy of individuals. So we see as a condition, basically two conditions to try to build these trusted smart statistics. One is that the data life cycle, it needs to be transparent, it needs to be auditable, so we can make somehow have the guarantees that what is being produced is valid, accurate. And secondly, that accuracy, privacy, and trust is built by design in the smart systems themselves. So, concerning standards, they are a fundamental base for this smart world, as the smart devices are being built by different enterprises, by different producers. And so in order to have all these smart devices connecting to each other via the internet, standards are very important. And of course, as the industry has realized the importance of guaranteeing somehow that the algorithm being used in this device are unbiased, there are standards being developed, standards that guarantee interoperability, but also the trust in the system. Many of these standards, in fact, many or in general all of them, they will include some statistical elements. So what is important for the statistics and research community is to get involved into this development, the development of these standards, and participate, integrate our existing statistical standards, not only our technical standards in terms of definitions, in terms of classifications, but also the standards that we have in terms of protection of statistical confidentiality, and integrate these into the technical standards that are right now are being developed and adopted by the industry. So in order to get there, we have a roadmap. We've tried to set up a roadmap, and right now at this stage we are launching a call to have some call for tender, so we could have some first proof of concept. And the idea is that in this first stage we would like to understand in what way this IoT data ecosystem could actually be used to produce official statistics, just to give life to an idea. And then second stage, so this is a phase that we are now running. We have launched the call, and the next year we should have some proof of concept running. They should be set up, and hopefully the results should be positive in the sense that we do find possibilities and successful cases of the use of these data from the smart systems, and then to work on constructing some prototypes where we will use some more specific or more directed cases where we will use it, and then with those identify what would be the quality challenges that are associated with building these new products, setting up sandbox infrastructures so we could test it, and also looking at what are the ethical considerations that we should be taking into account. So in the first phase is basically just try to find something that works. It's just a proof of concept, and then we will go into the prototypes. And then in the third stage, we will work towards having working products that will be fully operational and integrated with other statistics. So at this stage, we are really in the beginning with this proof of concept. At the same time, we try to see how can we use the technology developments that we see in this world that is emerging of IoT, and how we can use it to produce statistics without thinking great considerations in terms of the quality of the ethical issues. And then afterwards, in a future stage, between now to 2020, 2022, we'll be developing prototypes. So this leaves me to the end at this stage. This roadmap, of course, is a roadmap for official statistics, but for which it is fundamental that we work with the research community, and more importantly even, is that we all work with the industry, which right now is basically making this world happen. Thank you very much.
Thank you very much, Fernando. So this is Martin Kartenberg, Semantic Web Company, speaking for Big Data Europe. Thank you very much for this inspiring presentation and all the insights in the smartness of data and devices, I think, and mainly statistics. So we have learned a lot here. And in the meantime, I would like to ask our audience to start to type your questions into the chat. I see that some questions are already coming in, but please just go ahead. We will pick your questions now and hand them over to Fernando. Maybe 2 remarks until you're typing. So the one thing is, both slides that you have seen by Ivana and by Fernando, they are available to download in the handouts area of the panel that you see, and we will also provide it on bigdataeurope.eu website later on, together with the recording, latest in about 1 week, and we will send then an email to all registrants and participants of this webinar. And finally, feel free just to go ahead to put in your questions into the chat, and I will pick them and hand them over to Fernando. So I have one first question here that came in. It is about standards, and the question is, how is Eurostat involved in development such standards, or in the development of such standards, and how can others be involved in these developments, so beside the big enterprises, as far as I understand that question?
Well, we are starting to get involved. This is a new world for us in Eurostat and in official statistics community. We have been in contact with the Luxembourgish entity that is representing this country, Luxembourg, in ISO, where these standards are being discussed. Of course, it's Luxembourg because Eurostat is located in Luxembourg. It's the only reason. So it's at this stage, I would say there are more informal contacts with these bodies. We are then following the standards that are being discussed, and we are interacting with the industry in conferences. For example, we just had the last 3 days the European Big Data Value Forum, and where Eurostat has been made a presentation, and in this forum we have mostly industry members, and Eurostat has been presenting precisely these subjects, smart statistics, and the importance of standards. So at this stage, the contacts are mostly informal. Then in the future, then most probably we will need to formalize this a bit more.
All right, thank you very much. Maybe an add-on from my side. World Wide Web Consortium, W3C, is also, if somebody is interested to learn more about standards or also join in, there are community groups. So I think beside ISO, the World Wide Web Consortium is also a very good place to go. Thank you very much for that. Another question you answered partly, I think, but maybe I misunderstand. It's about the proof of concepts that you have presented. So the question is, how can we participate, or how can one participate, learn about the outcomes of the proof of concepts and the next steps immediately? So I think maybe the question is there some mailing list, or is there some website we can go and learn how this process is evolving over time?
Well, the best place to go will be the CROSS portal, which is a portal managed by Eurostat, where we basically join the two worlds, the research world and the statistics world. So we have an interest group on big data there. Normally, we share information via this channel. In particular case of the proof of concept, so normally there will be a report. So the proof of concept is this didn't even start, so we will have a report in a couple of years on it. But I think in 1 year time, we should have already some information that we will publish, and normally the channel will be the CROSS portal. Then if I understood, there was a question now to get involved.
Exactly.
So,
yes.
So at this stage in the proof of concept, so it's already launched, and now we think about what we will launch in the future. It will be prototypes. But either for the proof of concept or for the prototypes, the best way is to connect with the National Statistical Institutes. So Eurostat calls there directly to National Statistical Institutes, but of course the research community and the industry can join the statistical offices, and they can then participate in the calls that Eurostat will make in the future. So of course for the proof of concept we made a call, and we are preparing for the future additional calls in the coming years. There will be a call next year, in fact, and at the event of these calls, the research community can also participate. Of course, that our intention is to scale up our activities, and if possible, we'll even try to have some areas in the EU research program, Horizon 2020, or even and then the following one. Also, some areas that could be dedicated to smart statistics.
That's a very broad range of information. Thank you very much. And I think a very good hint and also call for action to take a look at national statistics at Eurostat, and for sure into the Horizon 2020 and the next framework program. A very interesting question. I'm also curious about how you answer that, is about the smart world that you have presented. By the way, I did not know that a smart fridge can also be used for television and for music streaming, so that was very nice. The question here is, how far are we away from such a reality, such a smart world?
So this is what we are also trying to understand, to figure out. I would say that smart technologies and smart systems, they've been around for quite some decades already. However, the technological conditions were not the ones that we have right now. So it looks like it's looking much more promising, or it looks like it will speed up. So this is our hope. But more importantly, I think that what it is important is that at a stage where the industry is already moving, that we are present there, that we are participating, in particular in the setting of the standards. This is what it is important. This might take still many years to come. I really don't know. But what I do know is that we need to be involved at an early stage so that we can make the smart statistics happen instead of having what they have with the big data, which it just happened to us. And of course, these have consequences. I didn't go into the details, but of course, that a big problem of big data sources is that as they were not designed for statistical purposes, they do pose some challenge in terms of the validity of the results that you can extract from it, in particular, the selectivity that we have in the data sets. So that's why we need to go back to that position of being in the design stage of the data capture. With the difference now that while in the traditional sources we were basically alone in designing the data capture process and designing the service and the questionnaires, now we will need to do it with other stakeholders.
Thank you very much for this, and I think that's a very, very good closing word. Also, I've put together, we have questions that are a little bit similar to the ones you've answered. So we are through our webinar today, but I think it's a good final closing word to say we have to work together to solve also these problems. That is what I interpreted a little bit into your last sentence, Fernando. So it's up to me to, on the one hand side, thank you, Fernando, very, very much for the insights you gave today into smart statistics, where we are, where we're going to. And also thank Ivana for her introduction for the Big Data Europe project, and that is ending soon, but I think has a very nice track record, and there's a lot of stuff everybody can take from there. So once again, thanks Ivana, and mainly thank you very much Fernando, and thanks to you all participants for joining in, for listening, and you will get a follow-up information. So have a nice day and see you soon. Bye-bye.
Thanks a lot. Thank you. Bye, everybody.
Thank you. Bye.